Mathematics, Grade 10, Monthly Review, Final Exam. Sign of binomial. Study the sign of minus 2x plus 12. Minus 2x plus 12 is equal to 0. Then x equal 6. Minus infinity into plus infinity minus 2x plus 12 equals 0. So x equal 6. X equals 6 minus 2x plus 12 equals 0. The sign of x is negative. So before x, we write opposite same. Sign negative, so here positive and here is negative. Sign of a product. Study the sign of f of x equal minus 25. First, factorize f of x, which is equal to x minus 5, x plus 5. X minus 5 equals 0, so x equals 5. X plus 5 equals 0, then x equals minus 5. Use table from minus infinity and plus infinity. Minus 5, 5, x minus 5, x plus 5, and f of x. When x minus 5 is equal to 0, then x equals 5. Sign of x is positive, then we write here minus minus plus. Sign of x plus 5 of x is positive, then we write minus plus plus. Minus 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 plus minus. F of x is positive when x between minus infinity into minus 5 and 5 into plus infinity. X belong minus infinity into minus 5 union 5 plus infinity. F of x negative here. So it is from minus 5 into 5. Sign of quotient. Study the sign of f of x. F of x equal x minus 5 over x plus 5 x minus 2. X minus 5 equals 0, so x equals 5. X plus 5 different than 0 since x plus 5 and x minus 2 denominator, so x different than minus 5. X minus 2 different than 0, so x different than 2. Draw a table from minus infinity into plus infinity. Solutions: 5 minus 5 2. From minus 5 to 5. X minus 5, x plus 5, x minus 2, f of x. X minus 5 is equal to 5. Its sign is positive, so minus 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 plus, opposite sign. X plus 5 different than minus 5, different than minus 5. Its sign is positive, so minus plus plus plus. X minus 2 different than 0, so x different than 2. Sign of x is positive, so minus minus plus plus. Minus different plus different minus 0 plus. F of x greater than or equal to 0. F of x less than or equal to 0. f of x greater than 0 here and here. So it is from x belong from minus 2 into 2 and from 5 into infinity. X belong minus 5 to open since different than union from 5 into plus infinity. Negative is from minus infinity to minus 5 and 2 to 5. X belong minus infinity into minus 5 open union 2 into 5 closed. System of linear inequalities. Solve 3x minus 1 greater than 0, 5x minus 10 less than or equal 0. First, 3x greater than 1. So, x greater than 1 over 3. 5x less than or equal 10. So, x less than or equal 10 over 5, x less than or equal 2. Draw number line. We have solutions 1 over 3 and 2. Solution of the first equation, x greater than 1 over 3, greater than, open since strictly greater than. Now, x less than or equal to, less than 2 or equal closed. So, the solution is here. Solution from 1 over 3 into 2 closed and open here. Now, function. Domain of definition. Domain of definition of a function is the set of all real numbers x for which we can calculate f of x. For example, f of x equal 1 over x plus radical x. So, we can say that x under the radical should be greater than 0. X here should be different than 0. So, the solution is domain of definition from 0 into plus infinity. Example. Find the domain of definition of f of x equal 1 over x plus 1. X plus 1 different than 0. So, x different than minus 1. Then the domain of definition is from minus infinity into minus 1 union from minus 1 into plus infinity. Or we can say that it is set all real numbers are except minus 1. Number 2. F of x equal x squared plus 1. The domain of definition here is from minus infinity into plus infinity. F of x equal radical x plus 1. X plus 1 under the radical. So, x plus 1 should be greater than or equal to 0. So, x greater than minus 1. Greater than minus 1. So, the solution from minus 1 into infinity. Find the domain of each function. Y equal 1 over x plus 5. So, x plus 5 different than 0, then x different than minus 5. Then domain of definition is from minus infinity into minus 5 union minus 5 into infinity. Number 2, y equal 4x minus 17. Domain of definition minus infinity into infinity to plus infinity. Number 3, y equal radical x plus 9. under the radical should be greater than 0. So x plus 9 greater than or equal to 0. X greater than or equal minus 9. Domain of definition from minus 9 into plus infinity. Last one, y equal x squared plus 99. Domain of definition from minus infinity into plus infinity. Variation of a function. Increasing function. Let I be an interval x1 belong I and x2 belong to I. If x1 less than x2, then f x1 less than f of x2. x1 less than x2, then f x1 less than f of x2. That's increasing. Also, if f of x2 minus f of x1 over x2 minus x1 greater than 0, then it is increasing. Decreasing function. If x1 less than x2, then f of x1 greater than f of x2. It is decreasing function. And if f of x2 minus f of x1 over x2 minus x1 is negative, then f of x is decreasing. Extremes of a function. Maximum and minimum. This point is minimum. This is maximum point. Local maximum. Local maximum. Local minimum. And here is local minimum. If the function is symmetric with respect to y prime or y, then it is even. If the function is symmetric with respect to origin, then it is odd. Even function have the y-axis symmetry. Y-axis symmetry. Odd function has the origin as a symmetry. Origin as a symmetry. A function is even if f minus x is equal to f of x for every number x in the domain. Example, f(x) equal 5x4 minus 2x squared plus 1. If this function is even, f minus x equal 5 minus x4, okay, minus 2 minus x squared plus 1 equal minus x squared is equal to x4 minus x squared is equal to x squared. Then f of minus x equal f of x. Then we can say that f of x, yes, it's even. A function is odd if f of minus x equal minus f of x for every number x in the domain. Example, f of x equal 5x4 minus 2x squared plus 1. Is this function odd? Let's try. F of minus x equal 5x squared minus 2x squared plus 1. So f minus x equal f of x. Then we can say that not odd. Now, exam review. Question 1. Given non-orthonormal system, the two vectors u and vector v. Determine M if u and v are orthogonal. U and v are orthogonal if u dot v equals 0. So x prime y prime equals 0. X prime x prime y and here y prime. So m plus 1 times minus 1, 5 times 2m equals 0. Minus m minus 1 plus 10m equals 0. So 9m equal 1. So m equal 1 over 9. Number 2. Determine the domain of definition of f of x. X minus 2x plus 3 greater than 0. X minus 2 x plus 3 greater than or equal to 0. So x equal to and x equal minus 3. Minus 3 to minus infinity plus infinity. X minus 2 x plus 3 x minus 2 x plus 3. X minus 2 is equal to 2 minus minus plus minus plus plus minus and minus positive negative. F of x greater than 0, so the domain is greater than 0 since x minus 2x plus 3 under the radical. So domain of definition is equal minus infinity minus 3 union 2 plus infinity. Number 3. Factorize p of x. P of 1 equal 2 times 1 cubed plus 5 times 1 square minus 1 minus 6 equals 0. Then x minus 1 factor. 2x cubed plus 5x square minus x minus 6 divided by x minus 1. We can divide it by 2x square, 2x cubed minus 2x square. Subtract 7x square minus x minus 6. 7x is 7x square minus 7x 0 minus x minus x plus 7 6x minus 6 plus 6 6x minus 6. Now 2x squared plus 7x plus 6 minus 2 is root, so if minus 2 is root, then we can divide by x plus 2 divided by x squared plus 2, 7x plus 6 divided by x plus 2, 2x into x squared plus 4x. So subtract here 7 minus 4, 3 plus 6. 3x plus 6, so it's equal to 0. And we can write that p of x equal x minus 1, x plus 2, 2x minus 2. Number 4. Find the domain of radical p of x. Radical p of x is equal to radical p of x is equal to x minus 1, x plus 2 and 2x plus 3. X x minus 1 equals 0, so x equal 1. X plus 2 equals 0, so x equal minus 2. 2x plus 3 equals 0, so x equal minus 3 over 2. The domain of definition of radical p of x is p of x greater than or equals 0. So, the table minus infinity plus infinity minus 2 minus 3 over 2, 1. X minus 1, x plus 2, 2x plus 3, p of x. X minus 1, its solution is 1, minus, 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 plus. X plus 2, its solution is minus 2, minus 2x plus 3 equals 0, so x equals minus 3 over 2, minus, plus, minus, plus. P of x positive. Domain of definition is P of x is positive, so domain is from minus 2, minus 3 over 2, union 1 into plus infinity. Question 2. Solve the following system of equations. 4 minus x equal negative and x plus 1 over 3 less than or equal 1 minus x over 2. First inequality, second inequality. Let's begin by first inequality. 4 minus x square less than 0. So 2 minus x, 2 plus x less than 0. 2 minus x equals 0, so x equals 2. 2 plus x equals 0, so x equals minus 2. So the solution, 2 minus x, 2 plus x, 4 minus x squared, minus infinity, minus 2 plus 2 plus infinity. 2 minus x, solution is x equals 2. Here sign is negative, so opposite, same. 2 plus x is equal to 0, its solution is minus 2. Here positive, so sign of x is positive, so opposite same. Minus plus plus. Minus plus minus. 4 minus x equal negative. So solution of the first one is minus infinity to minus 2 negative here and here. Union open since strictly increase and strictly negative 2 into plus infinity. Second inequality. X plus 1 over 3 less than or equal 1 minus x over 2. 2x plus 2 cross multiplication less than or equal 3 minus 3x. 2x plus 3x less than or equal 3 minus 2. 5x less than or equal 1, so x less than or equal 1 over 5. 1 over 5 less than that's the solution of second one. Solution of second one is minus infinity into 1 over 5 close here and open here. Now find the solution of the system. Put the solution of first inequality and second inequality. Minus 2, 1 over 5, 2. Solution of the first inequality is minus infinity into minus 2 union from 2 into plus infinity. Solution of the second inequality is from minus infinity into 1 over 5. The intersection of two inequality is solution of the two inequality is minus infinity into minus 2 and open 1 is the solution from minus infinity into minus 2. Number 2, simplify A. A equal sine 5 pi over 2 minus x minus 3 cosine x minus pi over 2 plus cosine 5 pi minus x cosine 13 pi over 2 plus x. First, 5 pi over 2 is 4 pi over 2 plus pi over 2 minus x minus 3 cosine pi over 2 minus x plus cosine 5 pi is 4 pi plus pi minus x plus cosine 12 pi over 2 plus pi over 2 plus x equal sine 4 pi 0 4 pi 0 12 pi over 2 6 0 is 2k pi. So sine pi over 2 minus x pi over 2 minus x here, so pi over 2 minus x is equal cosine x minus 3 cosine minus cosine pi over 2 minus x, it is sine x minus 3 sine x cosine pi minus x cosine pi minus x minus cosine x plus cosine pi over 2 plus x is minus sine x, so it is minus sine x equal cosine minus cosine 0 minus 3 sine minus cosine minus 4 sine x. Number part B, B equal tangent 3 pi plus x minus cotangent 3 pi over 2 minus x plus tangent 2 pi minus x plus cotangent pi over 2 minus x equal in tangent and cotangent k pi is equal to 0 3 pi 0 and 2 pi 0 tangent x minus cotangent 3 pi is 2 pi over 2 plus pi over 2 minus x plus tangent minus x plus cotangent pi over 2 minus x equal tangent x 2 pi 0 cotangent pi over 2 minus x is equal minus tangent x tangent minus x minus tangent x cotangent pi over 2 minus x, it is tangent x plus tangent x. 2 tangent minus 2 tangent is equal to 0. Number 3. Consider sin x equal 2 over 3 and x between pi over 2 and pi. X between pi over 2 and pi. Solutions here. Cosine here is negative and sine is positive. Calculate cosine x, tangent x and cotangent x. First, relation between sine x and cosine x. Cosine square x equal 1 minus sine square x. since cosine square x plus sine square x equal 1. 1 minus 2 over 3 square. 1 minus 4 over 9 equal now 5 over 9. Cosine square x. So cosine x equal radical plus or minus radical 5 over 9. But cosine x negative. So cosine x equal radical 5 minus radical 5 over 3. Now tangent x. Tangent x equals sine x over cosine x. Sine x is 2 over 3. Cosine x minus radical 5 over 3. 3 by 3 cancel. So the answer is minus 2 over radical 5. Cotangent x equal 1 over tangent x, which is equal minus radical 5 over 2. Consider non-orthogonal system a 3-point A, B, and C. Find the Cartesian equation of straight line D passing through B and having a directing vector OA. We need two vectors. First vector OA, coordinate 2 and 5. Second vector passing through B, let M xy. So the vector BM x minus xm minus xb, ym minus yb, so y minus 3. So find the equation xbm over xoa equal ybm over yoa. xbm it is x minus 1 over 2 equal y minus 3 over 5. Cross multiplication 5x minus 5 equal to y minus 6. 5x minus 2y plus 1 equals 0. This is the equation of straight line D. Number 2. Determine the parametric equation of straight line AC. Need two vectors, AC and vector AM. AC of coordinate xc minus xa, xc minus xa, yc minus ya. So xc minus xa is equal minus 4, yc minus ya minus 11. Vector AM, xm minus xa, ym minus ya. xm x minus xa 2, ym y minus ya 5. So xam equal p xac, yam equal p yac. So xam is equal to x minus 2, p xac minus 4, y minus 5 equal p minus 11. Then x equal minus 4p plus 2, y equal minus 11p plus 5. This is the parametric equation AC. Part 3. Write a system of parametric equation of line D passing through N and parallel to line x minus 7 y minus 2. Parallel to V double prime, so same vector, same direction vector. So V double prime, you can find vector V 7 1 and M x minus 2 y minus 3. X and M equal P V, y and M equal P y V. So x and M is x minus 2, P 7, y minus 3 equal P times 1. X equal equal 7t plus 2, y equal t plus 3. This is the equation of line B. 4. Prove that the two straight lines B and AC are secant when calculate the coordinate of their point intersection. First, AC x equal minus 4t plus 2, y equal minus 11t plus 5. This equation is parametric. Convert it into Cartesian. Find t here. T equal x minus 2 over 4 over minus 4. T here, y minus 5 over minus 11. T equal t, so x minus 2 over minus 4 equals y minus 5 over minus 11. Cross multiplication, we get 11. X minus 4 y minus 2 equals 0. That is the equation of AC. So u over u prime is equal 5 over 11. V over v prime equal minus 2 over minus 4. So u over u prime does not equal v over v prime. So the two lines are secant. Find the intersection of the two lines. 5x minus 2y equal minus 1, and second equation 11x minus 4y equal 4. Using calculator, find x equal 4 and y equal 21 over 2. So the intersection of the two lines B and AC for 21 over 2. 5. Calculate the distance from C into line B. Equal 5xc minus 2yc plus 1 over radical 5 squared plus minus 2 squared equal 5 minus 2 minus 6 plus 1 over 25 plus 4 equal minus 10 plus 12 plus 1 over 29 equal 3 over radical 29.
Part 6. Let G 2m plus 2 and 2m minus 1 be a point on delta. Calculate the coordinates of G such that AG is perpendicular to AB. We have given that AG is perpendicular to AB. Therefore, AG times AB equal 0, since they are orthogonal. AG is 2m plus 2 minus 2 and 2m minus 1 minus 5. Therefore, AG is equal to 2m and 2m minus 6. Now we need AB. AB is equal to 1 minus 2, 3 minus 5. Therefore, AB is equal to minus 1 and minus 2. AG AB equals 0. 2m times minus 1 plus 2m minus 6 times minus 2 equal 0. Minus 2m minus 4m plus 12 equal 0. Minus 6m plus 12 equal 0. Minus 6m equal minus 12. Thus, m is equal to 2. Question 5. Consider the function of define on real numbers by f of x equal x squared plus x plus 6x plus 5. C is its representative. Part 1. Verify that f of x equal x plus 3 squared minus 4. X plus 3 squared minus 4 equal x squared plus 9 plus 6x minus 4. X squared plus 6x equal plus 5 equal f of x. Verified. Part 2. Prove that minus 4 is the minimum of f. Then what is its subsystem? X plus 3 squared is greater than or equal to 0. X plus 3 squared minus 4 is greater than or equal to minus 4. Then f of x is greater than minus 4. Thus, f of x equal minus 4 admits a local minimum. Then f of x equal minus 4. X plus 3 squared minus 4 equal minus 4. Then x plus 3 squared equal 0. Then x plus 3 equal 0. X equal minus 3. That's its abscissa.
Prove that f is decreasing on minus infinity minus 3 and increasing on minus 3 plus infinity. So we write let x1, x2 belong to minus infinity minus 3 such that x1 is less than x2. So f of x1 minus f of x2 over x1 minus x2, and we substitute equal x1 squared plus 6x1 plus 5 minus x2 squared plus 6x2 plus 5 over x1 minus x2 equal x1 squared plus 6x1 plus 5 minus x2 squared minus 6x2 plus 5 over x1 minus x2. Plus 5 minus 5 gives 0, so it becomes equal x1 squared minus x2 squared plus 6x1 minus 6x2 over x1 minus x2. We factorize x1 minus x2, x1 plus x2 plus 6 x1 minus x2 over x1 minus x2. We take common x1 minus x2, x1 minus x2, x1 plus x2 plus 6 over x1 minus x2. It gives us x1 plus x2 plus 6. We have x1 greater than less than minus 3. And x2 is also less than minus 3, so x1 plus x2 is less than minus 6. Then x1 plus x2 plus 6 is less than minus 0. Then f is decreasing over minus infinity minus 3. Now we want to prove that f is increasing over minus 3 plus infinity. We have x1 plus x2 plus 6 equal to 0. We have x1 greater than or equal minus 3. x2 is also greater than or equal minus 3. So x1 plus x2 is greater than or equal minus 6. So x1 plus x2 plus 6 is greater than or equal 0. Therefore, f is increasing over minus 3 plus infinity. Now I want to construct a function of f. So we have x and f of x. We have minus infinity, minus 3, and plus infinity. In part 2, we said that minus 4 is the minimum of this function. So we put the minus 4. We said it was decreasing from minus infinity to minus 3. so we say it's decreasing and increasing from -4 to plus infinity. And this is the table of variation. Now we want to complete the following table. So substitute x in the equation of f of x. We have f of x equal x squared plus 6x plus 5. We start substituting the numbers. I'll do the first one. Minus 6 squared plus 6 minus 6 plus 5 equal 36 minus 36 plus 5. It gives us 5, so we write 5 here. As well as the second one, we substitute the same way and gives us 0. The third one gives us -3. The fourth one gives us -4. The fifth one gives us -3. The sixth one gives us 0. And the last one gives us 5.
Question 6. The figure to the right represents the curve seat of a function f. Part 1. Find the domain of definition of f. The domain of definition is from -2 till 2. From -2 till 2. Part 2. Calculate f of 1, f of -2, and f of 0. F of -1 is equal to 2. F of 1 equal to. F of -2 is equal to 2. F of -2 is equal to 2. And f of 0 is equal to 0. Part 3. F admits a local minimum at x equal, that's the local minimum at x equal -1, f of -1 equal -2. F admits a local maximum at x, that's the local maximum, at x equal 1. F of 1 equal 2. Part 4. Set up the table of variations of f. Here we put x, and here we have f of x. First we take -2, and then we take the -1, the 0, the 1, and the 2. F of -2 is 2, and f of -1 is -2. Then it is decreasing from 2 to -2. F of 0 is 0. Then it is increasing from -2 till 0. F of 1 is 2. Then it is increasing from 0 to 2. F of 2 is -2. That it is decreasing from 2 till -2. Part 5. Study the parity of C. We should see whether C is even or odd. So we get f of -1 and f of 1. F of -1 is -2, and f of 1 is 2. Therefore, f of 1 equal minus f of -1. Therefore, it is odd. Part 6. Solve graphically. F of x is equal to, and f of x equal -3. F of x 2. That's f of x 2. F of 1 is equal to 2, and f of minus 2 is equal to 2. Okay, now we want f of minus 3. F of minus 3 doesn't exist. F of minus 3 doesn't exist.